Ladies and gentlemen, it is now time for the main event. Everything we have worked on until now have been building blocks for the actual player comparison function that we are going to write to help generate our season stat projections. What we are doing now is chaining together everything we've done to date and turning it into a function that takes a data frame, the current player ID, and current player season as an input and outputs the projected stats for their next season. Once we have this, we can loop over it with every player available in the draft to get our projected stats for the next season. We're going to do it for this past season so we can take the real stats and measure how well we did. Let's define the function and call it player comparison tool and return projected stats. Our tool is going to take three inputs: a data frame, the current player season, and the current player ID. And again, we are going to return some projected stats that will ultimately convert into a data frame. Now, we can add in each piece one at a time, and before you know it, we will have our function ready. We've already done a lot of this work, we just haven't seen it all in one block of code. One more part we need to add at the beginning is the ability to catch ourselves if the player doesn't exist in the data frame. We can do this similar to how we look up a player and check to see if the current player ID and current player season match a row in the data frame. If not, then we will print that we can't find the player and continue on. So let's use a conditional if statement that checks if a value is none, and if it is, we print we can't find the player, and if it is true, we continue on with our function. So basically we're saying if, and if, and really our df season ID equals current player season and df player ID equals current player ID. And if any of those equal false, then print can't find player with ID and season, or we'll format current player ID and current player season. This needs to go away. And here we are just going to add in an extra here. So what we're saying is if the current player season and the current player ID, if any of these is not true and it's false, then we're going to print can't find the current player season, and we'll just return nothing. What comes next is we're going to look up the current player and find their row of data. So this is assuming that we passed that first if statement. We will use our for row in df iter tuples if current player season equals the row season ID and current player ID equals the row player ID, then we can safely say current player ID equals row player ID. And at that point we can break since we found our player. Then we will use our current player ID and current player season to create our current player vector array like before. And here I'm just going to kind of keep adding to it so you can see it broken out separately. And again, what I am going to steal is what we had used before. And that's our current player vector, which again, we turn into an array. And we're getting all of the normalized items that we will save. And next we can move on to our for loop, which creates a compared player vector for every row in the data frame, and ultimately the single distance number we are after to determine the player similarity. Remember all the nuances of vectorizing it. Once we have added the new column to our data frame with the distance values, we can sort the data frame and save it as a ranked data frame to slice. So here, that next step we'll add to will be the compared player data frame. First, we need that empty player distance list again, and then we're going to loop over all the rows in the data frame. So basically creating a compared player vector for each of the rows. And within that, as we're looping, is when we're going to pull back in our player distance. And when we're looping over that is when we're going to get that number that we're appending to our player distance list. And again, after we have created all those numbers, we can add that new column that equals the player distance. And from there, once we've had that player distance, is how we're going to sort and get the rank df by taking the sort values on the distance to where the smallest is at top. So then we will get a ranked data frame with everything sorted by the shortest distance, which will ultimately slice. Now we can add in the part where we find the 10 most similar players in rows 1 to 11 of the ranked df and look up their next season stats, then weigh them and sum them to project our current player stats. Remember that if a player's season is 2017-18, then we skip since there is no next season for them. We are going to return our projected stats value because we will need to run it into one more for loop after this. So from here, we are going to say, hey, these are the stats that we care about. And then we need to create an empty dictionary that we're going to use to project the stats. And this is where we're adding in all that goodness from before, where we're looping over the column in each of the stats. And we're getting the rank df, but only taking those 10 rows. Again, skipping the first since that's going to be the player compared to the player himself. We're skipping it if the season ID equals 17-18 because there is no next season for them. We're getting the weight. We're finding the next season by taking the row of the season ID and adding 1 to our season list index. We're getting that player next season stats by using our find player function, which is taking in our ranked df, the player ID in the next season. And again, if it's none, we're going to use that get attribute method to use the weights, and we'll be adding this to our projected stats dictionary for each of the players. And then finally, you'll see we return that projected stats, which is actually the dictionary at this point. There is one last finishing touch we are going to add to our model, and that is the weights for each stats. This will come in handy as we measure the effectiveness in our model and can help each of you to differentiate your own models based on some unique insight. By weights for stats, what I'm talking about is how much we care about each of the 8 stats we are projecting. In fantasy basketball, they all count for the same amount, but there is a chance we care more if a player is similar in points than we do in blocks. To add this touch, we are going to create a list with weighted values for each of the stats and then work this into our player distance section of the model. So if I take this, copy it, paste it, let's go to this section right here. And what I'm going to do is, for simplicity's sake, I'll just use 1 for each of the weighted values so nothing changes. And what we're going to do is add a weighted numbers list. And again, for now, I'm just going to input 1 for each of the numbers, which is basically saying for the points, minutes, field goals made, field goals attempt, I'm going to count each of them as 1. But as you can see, if I wanted one to be worth more than the others, I could say 1.2, and vice versa. If I wanted it less, I could say 0.8. So that's saying for the field goals made, only count that one as 0.8 relative to the others, which are 1. Then we're also going to add in a line of code that gets our weighted distance by multiplying the distance vector by the weighted numbers like so. So this is now, we're adding in something here to where we're going to say the weighted distance is equal to the distance vect, which we got right here. But now we're going to multiply it by our weighted numbers list. So we're basically saying, here's our distance vect. Now multiply it by the weighted numbers and save this as the weighted distance. From here, we will sum up the weighted distance instead. So let's take here, MP sum, MP abs divided by the weighted distance vec, and that's going to be divided by the length, the distance vect, and this will be equal to our number. So our updated player comparison tool now looks like this. Again, these are merely taking all the building blocks that we focused on one by one prior to this section. Now we have one last for loop to get our projections for every player. Let's look at that in the next section.